Okay, in this video, we're going to start talking about computer adaptive testing. And if you remember way back to the beginning of the course, we talked about one of the big advantages of IRT is not so much that you got to just analyze data you've already got laying around and have some kind of magic happen through IRT computed data scores. This doesn't really work that way, right? Data scores correlate with observed scores pretty highly, and if your correlation under observed scores is zero point 0.3, if you use data scoring, it's going to be a lot like zero point 0.3. It's not going to magically jump up or anything. So one of the big advantages, though, one of the reasons we do IRT, and maybe even the biggest in a lot of ways, other than equating and being able to give different versions of tests to different people, is computer adaptive testing. And computer adaptive testing is something that most of you are at least familiar with. It's been around for a good while now, so you probably have a good idea about how it works. And most people know more or less that, if you get items right, they get harder. As you get items wrong, they get easier. And we're really going to jump into here kind of what's happening under the hood. So this is all about the underlying algorithms and what's going on, the logic, the program flow, and then some pragmatics. I've been lucky enough to work on some cats. I've written them in PHP in my own server and just to play around with, and have helped define the underlying logic for some out there in the market. It's now under the SHL banner, but SHL, one of the biggest testing companies out there, hired early on me and Fritz Straskow to help with their CAD engine. And so I'm going to talk a little bit about that. I'm not sure they're still using it. I know at one point when it was Previsor and under that kind of label they were, and have been used, millions of times for different job applicants. So anyway, I've got some ideas about how it works in practice, and we'll talk about sort of some of the issues that come up. But let's first talk about some of the basic kind of approach to CAD here. So the basic idea behind CAD, as you know, is to use previous responses to determine, predict, how a person will respond to a future item, and you're going to pick this next item and re-administer and repeat. So essentially, if you think someone, based on previous responses, is fairly high ability, and we're talking about like an ability test here just to start, but the same logic holds for personality and whatnot too. But if we think somebody is fairly high in ability, we're going to choose a relatively hard item, because one of the fundamental principles of psychometrics is you learn more when you match people to items to people in terms of ability and difficulty, right? So when you give really smart people really easy items, you don't learn much because they're all going to get all the items right. So we've talked about that, several times through. But if you give really smart people hard items, you're going to learn a lot more about them, because you'll start to see, based on who misses certain items, kind of you'll be able to tease out people that are high ability but slightly higher ability than other people in your sample. And again, we kind of go back to looking at kind of the inflection point and curves and p-value differences and all that stuff from early in the semester to explain that. But that's a golden rule of psychometrics, right? You want to match the test difficulty to the ability of the sample. And that's kind of what we're going to do here. So that's what happens in CAD essentially, right? So if we have a person and we've given them a few items and we think they're fairly high ability, we're not going to waste our time giving them super easy items that you might have to do if you were using kind of conventional paper and pencil test, especially a broad test like an SAT or GRE, something where you really have to be able to measure the entire range of data with precision. CAT lends itself extremely well to those applications. And the reason is, we don't need to give those really bright people a bunch of easy items, because we know they're going to get it right. So we can just really hone in pretty quickly on their ability and then give them items that are fairly difficult, that match that ability estimate. So that's the idea. You're going to essentially, take a guess at how able they are. Let's say that, for sake of argument, that we think somebody's fairly able, we'll give them a fairly difficult item, then we'll see how they do in that item, and we'll just repeat that process over and over and over. So if they keep getting items right, the items are going to keep getting harder and harder. Once they start missing items, they'll get a little bit easier. But we're going to use and look exactly how that happens. To talk about that process in detail. But that's the basics of it. And here's a handy flow chart taken one of the readings, and I've kind of highlighted the super important part. So to start, and let me turn on my highlighter pen here, my laser pointer. You start with some kind of provisionally estimate. So if you can do this in an educated way, great. If you can't, you can start with even just a single moderately difficult item, and that's fairly commonly used. We'll talk about some other kind of ways to do it just a bit, but you start with, let's say, for sake of argument, just a moderate item. And what you're going to do is you're going to present that item. You're going to get the response. You're going to score it as correct or incorrect, and you're going to compute data. So this is kind of the key right here. This is computing data, and the data estimate will change based on the response to that item. So you can do this even with a single item to start. You can also, just randomly pick some items to start. A lot of different ways to do it. But you can compute data, and then you're going to ask whether or not a stopping rule is satisfied. If it's not, you're going to present that item. You're going to pick an item based on what we think data is currently, present that item, get the response, recompute data, evaluate the stopping rule, right? And just repeat this flowchart process over and over and over until finally we reach some kind of stopping rule. And if it's the end of the test, then you're just done, right? And we're not going to worry about test batteries and things like that just yet. So why do computer adaptive tests? What are some of the advantages of this? Well, I think they're relatively obvious in a lot of ways, but there's some other advantages that are maybe not obvious. One is we can give these things on demand. There's not sort of batch processing necessary. So I'm currently working with a certification company, and we do paper and pencil tests. We have to actually set up a time months in advance, and people have to plan on showing up. A lot of times they're flying all over the country. They're doing these other things where they need to essentially, you have to have a proctor there, and you have to do sort of prepare your materials and print things out and whatnot. So with a CAT, a lot of times you can do on-demand testing. So there can be testing centers that people can drop into whenever it's convenient for them. And you can do these one-off tests. And that's true not of just of CAT, but any kind of computerized testing, right? That's sort of always a perk of that. You don't need trained administrators so much. Like if you build a good CAT, you can have people just sort of show up. And you don't have answer sheets. So actually the test security. So people often think about computers getting hacked as a vulnerability, but actually paper and pencil is a lot less secure, right? Once you have paper and pencil of the items, you've got to have it stored somewhere. You've got to give it to a proctor. You have to print it on demand or keep it laying around. People can rip a page out of your test book and kind of take that with them as a security flaw. So really paper and pencil tends to be a lot less secure actually than computer based, presuming you've taken adequate precautions, of course. So you have a little bit more test security there because there's no hard copy. That's kind of jumping down to this last one here as well. You don't worry as much about test administrator differences. So if you set up a computer-based test with a time limit, you can have the software enforce that. You don't have to worry about certain exam proctors being, more liberal with time limits or things like that. So, there are differences. That's another advantage of any kind of computer-based, really, not just CAT. The big thing is, and another kind of general computer-based testing, which need not be CAT, is that tests are individually paced. So, if you have, let's say, an SAT kind of thing with multiple sections, people can start that as soon as they're ready to. So, there's a lot of kind of advantages here. Again, some of these just go into generalized computer testing. Computer testing, you can do things like videos. This is something that I've been exploring lately. And you can actually have video clips, and you can ask people about video scenarios that you can't do with paper and pencil. Again, that's not specific to CAT, but to any kind of computer-based. The big thing when you get into CAT over just generally, hosting a paper and pencil survey on a computer is you need significantly less time. And CATs are really efficient, especially for something like a broad-based test where, if the SAT, they need to have pretty good precision at the lowest levels of data and the highest levels of data and everywhere in between. And with CAT, you can just not waste any time giving people items that are just wildly inappropriate to them. So you really can get a lot more efficiency. And this is a big deal because you have to worry about test fatigue and examinee experience and things along those lines. So it's really important to have that, which is a huge advantage of CAT. So the other thing is CATs can give you a very accurate score over a wide range. So let's say that we had the opportunity to give people only 30 items for whatever reason, right? You get a much better estimate of ability with 30 items with a cat than you do with a broad-based test, because you can target those items, presuming you're pulling from a big enough item bank. So you get a lot of advantages there, just in efficiency and speed of scoring, and that's why cat has really become sort of the standard for a lot of testing, certainly online testing and employment testing and things like that. CAD is used widely. There's other kinds of testing people use too. There's things called linear on the fly testing and other kinds of things that aren't technically adaptive, but use computer algorithms and things to assemble tests very quickly. But really CAD, as far as like wanting to administer as few items as possible, you really can't get any better than a CAD. So there are some disadvantages I think we're talking about here. They're not going to be applicable for all subjects and skills. And again, that's going to be true of any computer-based test, right? So if you're doing a job simulation of having somebody do a very physical task, you can't really do that via computer as well as actually, kind of like think like a work sample type test. That's only going to be relevant for certain jobs, right? If you're talking about computer-based. Um, a lot of cats are not based they're usually based on item response theory, but item response theory is just not going to be applicable for everything that's in there. There's going to be hardware limitations, so detailed things, sorting tasks can be harder and less intuitive in some ways on computer than paper and pencil. Older people that are not as familiar with computers, that's becoming less and less of a concern, but that was certainly a big concern when when computer-based testing started. Um, Cats, you really have to do a lot of work up front in the item bank. You've got to have a big item bank. It's maybe the biggest disadvantage. So you think about, normally a test, if I want to assemble a 50 item test, I might have to write 70 items, throw out 20 bad ones, and I'm left with a 50 item test. With CAT, you really need to have 2 to 3 times the number of items in the bank compared to what you're going to use to get really any kind of benefit from it. So, you just have a lot more work up front developing a really good item bank, and you got to have really, pretty good calibrated items. So they have to be linked, in a very in a way that is truly accurate, right? It's very important that all these item parameters are on the same metric, and they're all linked together in order to be able to use that information to assemble a cat. So cats are also limited, and this is true of any computer-based thing, by the number of computers you have. So for let's say paper and pencil, you could have 100 people, you just print 100 copies, no big deal. But if you only own 20 computers, and if you have 100 people, you want to do a large scale administration, you really have to give some time to think, is it worth it to buy enough computers if we're never going to have this many people again? And the answer may be no, depending on the scenario there. So the other thing is there's not a ton of work even now, even though this has been out there for 20 years, on things like self-efficacy and what the user experience really, how it impacts the IRT models about things like, well, I see the items getting easier. I think maybe I'm doing worse, so maybe my self-efficacy goes down, and we know that predicts performance. So, how does that actually impact the CAD algorithm? These psychological variables that we haven't really don't really know a ton about even now after a couple decades. So other advantages and disadvantages, I'm sorry, we're actually just more disadvantages. Again, if people aren't terribly familiar with computer-based assessment, you can run into some issues there. Maybe they don't work as well on the computer, or maybe the computer's got some kind of issue, the screen's not bright enough, the font's not big enough, what have you. There can be some disadvantages there for CAT. I think this is less of a problem today, and certainly kids today, are growing up taking tons of assessments on computer. I don't know. I said kids today sounded like I'm ancient, but kids today are not going to have that issue. But if I give this to older workers who are protected obviously under Age Discrimination Act, they may have more issues with it than younger people would. Uh, One of the big issues you run into with CAT is explaining what is going on, right? So imagine relatively low ability people in particular, and they feel like they got a harder test than their coworker did, or their other friend did as a job applicant, or coworker for a job promotion scenario. Um, you really need to get into the weeds to explain to that person why getting a harder test is actually a good thing. It means they're getting harder items, it means they're probably doing better on the easier items, but they don't always see it that way, right? And certainly in some employment settings where there's maybe not a lot of trust, you could be, you find yourself in an unfortunate circumstance of having to explain to somebody who got passed over for promotion why that is fair, even though they got different items. And you know, for somebody again that might not understand the details or even have the wherewithal to understand what's going on here, that's not a good position to be in. So that's another one. With a cat, a lot of times you can allow people to go back and change their answers. Some people don't like that from a user experience. And that's because early on, people figured out a kind of a clever way to game the system. What they would do is miss two or three items in a row on purpose and then get a bunch of easy items, right? And so the initial kind of algorithm thinks, well, they missed five items in a row. They must not be very smart. They get a bunch of easy items that they can get correct, and then they can the test ends because they get a convergence that your ability estimate is fairly low, but then they can go back and change those initial answers and end up with 100% correct responses and get a kind of an off a chart high theta estimate. So people kind of figured out how to game the system really early on, and for that reason you can't really let people go back and change their responses very easily.